Welcome to the Epic Flight Academy Commercial Pilot Course. Remember our 3 keys to success, and please hit that subscribe button. Our topic today is airspeed indicator markings and VX and VY airspeeds. Our primary reference will be the 172S POH, the one with the NAV3 avionics option. Airspeed indicators have colored arcs, and these arcs, or ranges, have specific meanings for a pilot. Pictured here is both a mechanical or round dial airspeed indicator and an airspeed indicator from the G1000. Notice the color arcs. Airspeed indicator markings are shown in section 2 of your POH, in figure 2-2 on page 2-5. The 3 color-coded arcs or operating ranges shown on the airspeed indicator are defined by specific V-speeds, and you can see those here. The white arc is the full flap operating range bordered by VSO on the low end and VFE on the high end. The green arc is the normal operating range bordered by VS1 or VS at the most forward CG with flaps retracted at the low end, and by VNO at the high end. The yellow arc is the range where operations must be conducted with caution and only in smooth air. This arc is bordered by VNO and VNE. Now let's turn our attention to VX and VY. To understand these speeds, we must read about performance in Chapter 11 of the PHAC, starting on page 11-5. And right away, we find out that thrust and power are not the same thing. Thrust is simply work, or force times distance. Power is the rate of doing work, or simply force times distance divided by time. This excerpt from the PHAC explains the difference. We'll find this on page 11-6. I'll give you a minute to read and study.
We sometimes use the terms power and thrust interchangeably, typically measured in horsepower or kilowatts. We can think of power as a motion. 2 basic factors or combination of the 2 factors contribute excess power above that required to maintain level flight, or the aircraft climbs by converting airspeed to altitude.
Welcome back. Now, consider VX, or the maximum angle of climb. We want the aircraft to do the maximum amount of work that it can and get us aloft at the steepest climb angle as possible without stalling. Now, this work is done through the propeller. The maximum work the propeller is doing, or said another way, the maximum thrust that the propeller is making, is when the propeller is at its highest angle of attack. In flight, this higher pitch attitude is a lower airspeed. When the aircraft is at this higher pitch attitude, the propeller is at its maximum angle of attack. It produces the most thrust, or in other words, the propeller is doing its maximum amount of work. At this point, we don't care about how fast we're getting aloft, the rate of climb, but simply rather how high we can get in the shortest distance. This is VX, and you can see VX and VY depicted here. Now consider Vy, or the maximum amount of altitude in a given period of time. Now we are no longer concerned about getting aloft at the steepest possible angle, but rather getting as far aloft as we can in the shortest period of time. Well, once we put time into our thinking, we are now concerned with power. And if we want to get aloft in the least amount of time, then we want the airspeed for the maximum excess power available. Okay, well, in that case, then we need to look at two curves supplied to us by the aircraft manufacturing engineers. Number one, the minimum power required to stay aloft without stalling or descending. And compare that curve to number two, the maximum power that is available. We see these curves shown in the PHAC in Chapter 11 in Figure 11-9 on page 11-8. The minimum power curve required to stay aloft is the brown curve. The maximum power available is the red curve. Now let's say, for our example, that we're at 5,000 feet MSL. The vertical black line is the maximum difference between the two curves, and the corresponding airspeed at the bottom of the graph will be, you got it, Vy. Now, what happens to Vy speed as we go up in altitude? We know that Vy decreases, and this is shown in the POH in Section 5 on performance in Figure 5-6 on page 518. But why does Vy go down with altitude? The answer lies with the red line in our excess power graph. Notice here we're showing power available as the red line at 5,000 feet MSL, and then again as the dark blue line at 10,000 feet MSL. So why did that dark blue line fall over like that? Because of altitude. There's less atmosphere available to the engine, so less total power, so less excess power available. And here's the key. Notice as that curve starts to fall over due to higher altitudes, that the maximum excess between the two curves moves to the left. In other words, toward a slower airspeed. Well, folks, this wraps up our review of airspeed indicator markings and VX and VY. Join us next time.